All right, welcome everyone. Going to give folks a few moments to join, and we will start off first with a quick intro about Acelab, show you guys how to find today's presenters on Acelab, and give you a little preview of some of the newer tools we're building. And then after that, we'll go ahead and proceed with today's CEU approved event presented by the group at Tnemec. We've got Andy Hoffman here today, who's going to be giving the presentation on mitigating thermal bridging with fluid applied coatings. So very excited for that. And it looks like we've got a good amount of folks in the room. So Helen, if you want to go ahead and get started with our intro, we can get going.
Sounds good. Thanks, Bo. Hey, everybody. All right. Today, I'm going to talk about how you can get in touch with the wonderful folks at Tnemec and then show you all some fun stuff that we have coming out soon. So from your Acelab homepage here, you can always type in any brand name that you need, and you will be able to click here and go to their brand page. Make sure you have brand selected here. So I'll do this in a second. One other thing I wanted to point out is that after y'all attend today's webinar, we will start a conversation for you based on kind of what you complete in the poll in terms of information you'd like for following up. And that'll show here. You can always click on this button. It'll take you to all of your different conversations that you have with different reps and things like that. Also with our team, we if you reach out for product recommendations, we'll put something in conversations as well. So jumping to Tnemec's page here, we get a nice image about a nice historical image there. This is about the company. If you want to get in touch with these folks, you can always hit contact here. Again, that'll start off a conversation within your Acelab portal. Quick note about that, anything that you might respond back from or they respond to you, you're going to see that as an email as well. So you can log back into your Acelab account, but you can also just respond from your email. We'll keep a record of that as well in the conversation. Scrolling on down, we'll see some information about the products. And then here we have all their different products, all their different coatings. So one thing that's great to do is that you can save some of these. I'm going to go ahead and take a gamble here and save a few of them to general research. And then what I can do there is I can hit compare. Or maybe not today. I'll jump into this other one just so you can see what they look like all next to each other. So jumping in here, you'll notice I have some different features, and that's because I am previewing what is to come. So again, I'll jump into coatings here, and we'll have their products here. And just scrolling down, if you're not familiar with Acelab's comparison, we take all the different products that we have, put them side by side. So what you'll see here, like you said, it might be a little different than what you see. We've launched schedules here as well. And so what this allows you to do is anything you've saved into comparisons, it's going to create more of a kind of column format for you. All of these columns are custom. So it can look like this. I'm going to jump into a simpler format for you just to talk a little bit more about what's coming and help illustrate this a little bit better. But so this is my clouding schedule, and this is on a project basis. We also have this function available for a firm library. You can use those same function, but you can use it very differently. So here, for example, this is going to be something that I might share out with my client and kind of use it as their tracking that approval process so they can control what they want, what they don't want. Again, all these columns are custom. So you can pull in data from our database, but you can also add your own items here, and world's your oyster, as many columns as you want. So lots of ways to use this. Folks are using this to kind of create views for their contractors, to create views for their clients, again, help with that approval process. And then we also have a lot of folks using this as a library function, building out client libraries, geographic specific libraries, and also, you know, kind of keeping a record of all their frequently used coatings and different products like that. Hopefully allowing you to hit the ground running in the future, because if I like some of these things, I can just copy and paste them into my next project. So if you want to meet with me, we can talk a little bit more in depth about this. I like to learn about your firm, and then we can kind of tailor it based on that with how we want to use this new functionality. All right, I will pass it back to Andy and Bo.
Great. Thank you so much, Helen. Yeah, if you're interested in learning some more, feel free to respond yes to the poll that we've got up, or I believe Helen will drop her meeting link in the chat. You can use that to book a meeting directly. Quick housekeeping item from me. This is an AIA-approved event. We did ask for AIA numbers upon registration. I'll also send over a form in the chat momentarily in case you're worried you didn't include your AIA number there, or if you'd like to request a certificate specifically. Other than that, just want to encourage folks to please ask questions throughout today's event. We should have some time to get to some of those live, and if we don't, we'll have a record of it so we can follow up with you afterwards. All right, awesome. Without further ado, Andy, feel free to take it away whenever you're ready.
Perfect. All right. Thank you, Bo. Yeah, so there'll be plenty of time for questions. I like to try to get through this, presentation portion in, 30, 35 minutes. There's plenty of time for any dialogue or discussion that we may have there at the end. As Bo and Helen talked about, when we talk about mitigating thermal bridging with fluid applied coatings, thermal bridging is becoming a lot more prevalent here as energy codes get more stringent. And so I'd say the last 7, 8 years, and real aggressively, I'd say the last 3 or 4 years, Tnemec has been promoting, using coatings in lieu of structural isolator pads or other ways to mitigate, the thermal bridging risk. So we'll kind of dive right into that and talk about that in a lot more detail here. The first several slides are just showing it's AIA accredited, so I'll just kind of buzz through these real fast. As Bo mentioned, with your number, we'll give you credit for this. I'll pause on this slide just real quick for the GBCI course number in case anybody needs that. That number is 09200254445. So the majority of the presentation will just talk about, thermal bridging and how these fluid applied coatings can be used for new and existing buildings without having to alter the structural design elements. These are a real easy use material that can be used to kind of mitigate that thermal bridging risk. And the big focus will just be and we're talking about, highly conductive materials like steel. All we're trying to do is get that surface temperature above the dew point to mitigate that condensation risk. So those are kind of some of the areas we're really focused on today. I'll start out defining a couple of key terms I'll reference a lot during the discussion. So I'll kind of define those on the front end. We'll talk about insulation coatings in general, just kind of a broad area of uses that they can be used for. And then we'll kind of talk about, aerogel, what makes it unique and why that really helps in driving the thermal performance of these materials. And then the majority of the time we'll spend on, thermal bridging, what it is, in case histories of where these type of products have been used. So one thing I'll talk about quite a bit is thermal conductivity, or K value. And this is a intrinsic material property, defines its ability to conduct heat. Unlike your home insulation in your walls, lower the number, better the insulator. And one thing we like about the K values is independent material thickness. So whether the product's at 2 inches like an insulation material, or it's 50 mils or 100 mils like a fluid applied insulation coating, that K value number is constant regardless of thickness. So it allows you to kind of compare the properties, insulating properties of one material to another without necessarily needing to know its thickness. Generally, it's going to be seen in milliwatts per meter Kelvin, but just keep in mind, lower the number, better the insulator in terms of thermal conductivity, or K value. And on the flip side, any product with a known K value does have an R value. And, on a lot of manufacturer data sheets, they'll list the K value and they'll also list the R value. Now, when you're thinking about fluid applied insulation coatings, these are generally, at a fraction of an inch. So our values are reported on an inch, and these are great numbers that we report on data sheets, but they're really not all that relevant just because we're not going to put these on an inch thick. It's just not realistic. It's not cost effective. So we're finding that niche where, 1, 2, 3 coats of these materials is very beneficial. And that's what we'll talk about here in this presentation. We've all seen our local weather channel guys enough. I don't need to spend a lot of time defining dew point humidity, but I just like this slide because, again, all we're trying to highlight when we use these on like steel penetrations is we're just trying to get that surface temperature above the dew point to mitigate that condensation risk. And, the relative humidity in space is a big driver in determining that interior dew point. So as long as we understand those 2 factors, then it really helps to better understand what we're trying to do in terms of getting that surface temperature above the dew point. When we think about dew point of conditioned buildings, again, like I mentioned, the relative humidity is a big driver in this. You can see on those 2 office spaces, both 70 degrees Fahrenheit, a 10% or 10% change in the relative humidity increases that dew point by 7 degrees. And all we're, again, trying to do is get that surface temperature above that dew point. So we need to know that interior temperature and humidity, to know what the target is that we're trying to get the surface temperature to. So with insulation coatings, ceramic or glass spheres has been the insulating means up until, I'd say, the last 10 years, where aerogel became an option. You type aerogel in any search engine, it's going to come back the best insulating solid in the world. It's been developed in the late 30s. The reason it hasn't really been used in like coatings up until the last 10 years or so. It's been a challenge for the aerogel manufacturers to make large batches of the aerogel particles. They find a way to kind of optimize that process and the treatment process of the particles where that can happen now. That's why you're seeing aerogel particles utilized in coating formulations now. Aerogel is a very unique material. It's always important to highlight that's a amorphous silica aerogel, so it's not the crystalline silica that kind of has the harmful connotations around it. So no harmful effects here. Actually, aerogel, to speak to the kind of safeness of the material, aerogel's in a lot of makeup foundations. So if you can smear it on your face, it's probably safe to put it in a coating. Tiny particle sizes, we're talking microns to millimeters. That way we can really maximize the amount of aerogel we can get in the coating, but still get it to spray apply like us coating manufacturers like to see. A lot of air in the material, and it's very water repellent. So incredibly hydrophobic. So if I took some aerogel and just kind of crush it up in my hand, put some water in my hand, the water just kind of beat up and roll around. So when you think about putting this on your steel on your building, it's hydrophobic, so it makes it very tough for any water to penetrate that coating film. Long and consistent service life. So the shelf life of the aerogel would actually be determined by the bag they had put it in. So the bag would break down and decompose long before aerogel started to lose its thermal properties. And then there's the thermal conductivity again. So remember, lower is better. So the thermal conductivity of the raw aerogel particles themselves is about 12 milliwatts per meter Kelvin. So to give you a comparison, polyurethane foam is a very good insulator. That's about 28 to 30 milliwatts per meter Kelvin. Calcium silicate, perlite, mineral, those are all good insulators. They're about 40 to 45, generally speaking. So it just gives you an idea of just how good of an insulator these aerogel particles really are. So this is just kind of a slide, kind of show you what's going on at the microscopic level within these aerogel particles and why they work so well. So on your left-hand side, you're looking at the 200 nanometer scale. What that means is within one fiber of an insulation material. So whether that's a perlite, calcium silicate, whatever the material is, within one of their fibers, you can see those red balls or these gas molecules able to bounce around freely and contact each other. Which at the top of the slide there, you're seeing the definition of conduction, which is the transfer of heat from molecule through another substance. So when they're bouncing around contacting each other, that's how they're transferring heat. On your right-hand picture, you're looking at within an aerogel particle. You can see within an aerogel particle, it's forming this bird's nest or this lattice network, which really restricts the ability of those molecules to do that same thing. So again, just down at the nerdy microscopic level, what's going on within an aerogel particle and why they work so well at limiting that heat transfer via conduction. So then what coating manufacturers like Tnemec do, they take either the ceramic or glass particles, or like in Tnemec's case, they take the aerogel particles and they formulate these in an acrylic binder. Generally, these are water-based acrylic resins, maximum operating temperature in that 300 to 350 degree Fahrenheit range. So the aerogel particles could obviously go significantly higher than that. So the limiting factor is the acrylic binder. And you want to use these as part of a coating system so you can get a good corrosion-resistant primer. Those are compatible with zinc-rich primers, epoxy primers, and you get acrylic top coats, you can get urethane top coats. So you can really tailor the entire coating system based on the substrate, the level of surface prep and the exposure. And it's, I just want to have testing on that full system as well. This is just kind of a real quick snapshot of the wide range of uses that these insulation coatings can be used on. We really kind of lump the condensation control and thermal bridging into one. So I'll kind of just briefly talk on corrosion insulation. When you use traditional insulation, you wrap a pipe with insulation, and there's an air gap between that pipe and the substrate, where that's where the fluid applied insulation coatings are intimately bonded to the primer. So you got that intimate bond, so there is no air gap for that corrosion under insulation to initiate. Energy efficiency is pretty straightforward. There's thermal properties in these materials so they can help keep something cool, help keep it warm. So it can just really help the thermal stability of the equipment and the assets. And personal protection is another one we will use a lot in food plants or process and manufacturing facilities where they may have a hot tank where instead of having to cage it to keep people around it, keep bumping into it and getting burned, you can put a coat or two of these materials on it. Now they have that safe touch properties so they can kind of protect the personnel. So again, just kind of a snapshot of the wide range of uses these materials are used in. But again, we'll just kind of highlight in the thermal bridging and mostly the condensation aspect of the thermal bridging issues. So with that, Bo, before we dive into thermal bridging, it's a good time for your poll question.
All right, one moment. Still here. Round one. All right. Here we go. Sorry about that. All right, poll is up.
Great. Yeah. So as we get into thermal bridging, there's the poll question, just kind of roughly what percentage of your projects, require some means of mitigating thermal bridging, whether that's less than 25% or between 25 and 50% or more than 50%. So that's just kind of the poll question we kind of throw out there to gauge, how often you're seeing thermal bridging come up on your projects.
I'm gonna give everyone like 10 more seconds to respond, and then
Okay.
we can go ahead and share the results and see what people said.
Okay, great.
All right. Looks like we've got a great number of responses, so I'm gonna go ahead and end. And yeah, it's like fairly even split, but most people saying more than 50%.
Terrific. Well, we got the right audience, and hopefully this resonates well with what we're going to talk about the rest of the way. So with that, I'll keep rolling along. Thanks, Bo. So as we get into the thermal bridging aspect of it, again, this is kind of the meat and potatoes, so to speak, of the presentation. As we get into thermal bridging, I always like to define a thermal break on the front end, because when you think thermal bridging and using thermal breaks to mitigate that concern, you think you need to actually physically break that steel. But if you look at the kind of the criteria of the definition of thermal break, it's not really calling out a physical break in that member to meet the criteria. So there's really two components of a thermal break definition, and it's element of low thermal conductivity placed in assembly, which I've obviously kind of beat that enough. The low thermal conductivity aerogel particles that are incorporated into the spray applied coating, so we kind of check that first box. We need to use that in a manner to reduce or prevent the flow of energy between conductive materials. So as we'll kind of go along here, we'll show you how we're meeting that second box. So even though we're using these coatings that aren't in a manner that aren't actually physically breaking those steel penetrations, we do meet the criteria of a thermal break by definition. And we'll get into more detail on how we meet those here as we go on, but just kind of keep that in the back of your mind that you don't necessarily need to be a physical break in order to provide that benefit. So this is a office space that got converted to a laboratory in the Boston area. So when they changed it to a laboratory, the RH in the space increased by about 20%. So they go through that first winter time, they're starting to see, frost build up on the aluminum window frames during the warning time as it warmed up over the day. It would kind of melt and just kind of be a watery mess inside that laboratory, which is obviously not something they wanted to have in that space. So we're able to mask off the windows in the surrounding areas, do some little hand tool prep, put on water-based epoxy primer, spray on 2 coats the water-based aerogel insulation coating, and top coat it with a water-based acrylic. So they have a full water-based system that they certainly appreciated in rooms next door, and then top coated in their brown color. So we have a thermal imaging camera, so we're able to kind of take a look at the surface temperatures and give you a real good idea of what's going on at the surface in terms of temperature. So we took that in the first winter this was installed. And as we kind of went in their space, and the first thing I saw was kind of some beads of water, and I got a little nervous for a second, but if you look at the picture, the beads of water are just on the rubber gasket. So the frame itself that got the aerogel insulation coating were bone dry. So we used our thermal imaging camera to take some spot readings. And you can see the picture on the right is taking a spot reading of that rubber gasket where you saw the beads of water. It's 47.1 degrees. The picture on the left is taking a spot reading of the aluminum window frame that got the aerogel insulation coating at 68.5. So you're seeing a 21-degree difference between those two surfaces, which is why in the 9 years now that this application has been in place, they've no longer seen condensation on that frame itself. So again, those FLIR imaging cameras are just a really good way to kind of take a snapshot of the surface itself in terms of the temperature. So issues related to thermal bridging, condensation inside the building envelope is not something you want to have. Obviously, reduce R value of the wall assembly. It can be a big problem. ASHRAE If you have a hard time sleeping at night, download the ASHRAE 90.1 standard, and I promise you, start reading that, and you'll fall right to sleep. I've read it numerous times, and I still really have a hard time really fully understanding the document. And they talk about all commercial construction and residential properties above 3 stories, and kind of meeting an effective R value of that assembly. So really kind of highlight, the assembly R values that you need to meet. Mold and mildew is another issue. Obviously, in a building envelope, you don't want to mess with. And structural issues, if it got to really extreme, can be a problem that obviously no one wants to have. And as we look at ASHRAE 90.1, the big thing that I always pull out from ASHRAE 90.1 is they talk about continuous insulation. So you can see highlighted there, continuous insulation is defined as insulation that is continuous across all structural members without thermal bridges. So if you think about a canopy on a building, a lot of times you'll have steel beams running through from inside the building through the wall outside, supporting these canopies. So when that steel is punching through that wall, that insulation is no longer continuous. So we're looking at materials like our aerogel insulation coating to put it on those steel members then, which can now make it continuous as it ties back into the wall insulation. And we'll talk more about how we're kind of recommending you use these materials here in a couple slides. So as we talk about thermal breaks, what traditionally has been used are physical breaks. So you take your steel member, you break it in half, flange it, and put a pad in the middle and bolt it back together. These are generally 1/4 inch, 1/2 inch, or inch thick pads. Big kicker here, they need to be accounted for in the structural design. So you got to be kind of count for these on the front end. It can make it a little more challenging to design for these. Thermal conductivity of these pads is greater than 260 milliwatts per meter Kelvin. Remember, lower is better. I mentioned the raw aerogel particles themselves is 12. When you incorporate the acrylic binder and all the other additives, the finished product's about 35. So it's still 7 to 8 times more efficient in terms of thermal conductivity than the pads itself. So if we take that same really highly sophisticated detail here, like it's very basic drawing, but you get the idea of what we're trying to do. So you got your vertical wall, and then the dark gray is representing, say, your steel member punching through the wall. So what we're saying is now no longer don't break that steel within the wall, keep it continuous, and apply the aerogel insulation where the red box is there. So we're saying apply 2 coats for a total of 80 to 100 mils, 18 to 24 inches inboard through the wall, 18 to 24 inches outboard, and that's it. And by doing so, we can shift the condensation point where it's not happening on that steel surface on the inside of the building. When I give this presentation, live in architect's office, I'll generally get a couple questions at this point. So I usually get asked, why 18 to 24 inches? Why are you not coating the entire beam? My first answer is, well, you can. We would love you to. We would sell more coating that way, but it's not necessary. And the reason is we looked at 10 different steel sizes, with the biggest one being a W30 by 108, which is a pretty good chunk of steel. And we looked at those 10 different steel sizes to determine the point in which that steel beam became infinite, meaning the point in which that steel beam already took on the ambient air temperature anyway on the surface. And it was anywhere from 12 to 21 inches depending on the size of the beam. So beyond 21 inches on the interior side, that steel surface is already taken on the ambient air temperature, so there's no longer a risk for condensation. We also get asked, why 80 to 100 mils? How do you get to that film thickness on this 18 to 24 inches? Again, we looked at those same 10 steel sizes, and we used an interior air temperature of 70 degrees with an RH of 35%, and we used a -10 exterior temperature. And with our material, we needed about 67 mils of coating thickness when applied on the 18 to 24 inches inboard and outboard to be able to mitigate that condensation risk and get the surface temperature above the dew point. So we recommend 2 coats for 80 to 100 mils total DFT. That way we got a little bit of safety factor built in there by a little higher film thickness to count for maybe a little colder space, a little colder outside, maybe a little more humid in the interior space. But if the conditions are really extreme, we can take those conditions, air temperature, humidity, outside temperature, and we can really tailor, customize the coating thickness. But generally speaking, the 2 coats and 80 to 100 mils covers the majority of thermal bridging applications that we get into. Another thing I'll get here is, you might have noticed when I showed the window frame example, there's a little bit of texture to the aerogel insulation coating, and that's just by nature of all the heavy load of the aerogel particles, it is a little bit of a textured product. So it's not, necessarily architecturally smooth like a car finish that sometimes you like to see. So you take this detail like this, and a lot of times we'll see like canopy supports on the exterior side are exposed visibly, and they don't want to see either that 100 mil lip before the aerogel insulation coating stops or the texture of the material. So we're able to then just apply it on the 2 feet on the inboard space and not take the coating outside and double the thermal resistance or double the coating thickness and achieve the same thing. So we have the ability to kind of manipulate the design a little bit. So the 18 to 24 inches inboard and outboard is our generic recommendation, but we have the ability to alter that based on the thickness of the coating in a given detail. So we're often sent, details for projects that we can kind of help with the designer and our local sales rep to kind of customize the coating thickness and the extent of where it's applied to kind of meet the thermal bridging risk. So here's just kind of a down and dirty demo that we'll take to trade shows. It's just a 3-foot continuous I-beam where half of it has the aerogel insulation coating, the other half just has an epoxy primer. We'll just fill the chest with ice to kind of simulate the interior of the chest is a really cold day outside, punching through the walls of the chest of the building to the interior space. Again, it's just one. We'll take the imaging cameras again to highlight the difference in the surface temperature. So again, in this case, you're seeing about a 10-degree delta between the epoxy primer side and the aerogel insulation coating side. So, and this is a really good demo to take to trade shows because you can certainly feel a much bigger difference, but then this just highlights the difference with the FLIR camera as well. So up until this point, we're talking, steel penetrations, whether it be roof penetrations, balcony penetrations, and we're talking about controlling the condensation risk. We've also done a lot of third-party modeling with engineers in terms of looking this on concrete. And when we put this on concrete now, particularly balconies, now it becomes an energy savings play. And so in this particular picture here in the bottom, we did a detail where we modeled coating the entire balcony slab, in this case, which is 7 feet, or just coating out 2 feet and doing a 2-foot rubber band. So we're just coating the top, sides, and bottom of that balcony. So we're just coming out 2 feet from the window wall or curb, whatever the design may be, and putting on 2 coats for 100 mils. Again, rubber band approach, top, sides, and bottom, 2 feet out from that window wall or curb design. And in that case, we can cut down on the heat loss through that slab by just under 20%, what you're seeing in this graphic here. So again, and there's really no difference between coating the entire balcony or just doing the 2-foot rubber band. Just so much mass in that concrete itself. Or taking the coating out, farther didn't really have much more of an impact. So just doing that 2-foot rubber band, top, sides, and bottom, you can cut down the heat loss on that slab by 20%, which can be pretty significant when you think about a high rise and has all sorts of balconies sticking out. Here's just kind of some pictures of the coating being applied to a balcony. Here you can see the yellow is the insulation coating. You can start seeing how the flashing's applied, and they'll come back with other things. Obviously, that's a water-based acrylic, so it's not a traffic deck coating by any means. We've tested with other manufacturers and also have our own kind of traffic deck system that we can then put over top. Here's some other pictures, some balcony pictures. You can see on the underside there, you can see the yellow insulation coating sticking out, 2 feet there. And that project I'm showing here, they came back and did a mock-up with their waterproofing membrane. So this is one where I would personally, if it was my project, I would take that 100 mil lip and just kind of feather it out to kind of minimize the transition of where the insulation coating stopped and where the waterproofing membrane came in. But really, they were fine with it. They didn't have any issues with it here. And you can see once you get that, particularly a darker color like this gray is, it really blends it in really pretty well. And just some more pictures, some balcony applications. This has become a pretty strong application for us, particularly in the Northeast, where energy codes are getting a little more strict, renovating older buildings or getting buildings up to meet newer energy codes, where every little bit they can do really makes a big impact. So this has become a really go-to product for them, particularly in the Northeast and some of these balcony retrofit projects. So some advantages of using the aerogel insulation coatings, shop or field application. I would say when we first started using this material in, kind of this thermal bridging space, I was seeing a lot of shop applications. I would say that's really shifted to more field application. I would say it's probably 80-20 field application versus shop. And I think that's, one is a very easy application. It's one component, water-based. You can spray it with something as simple as a handheld hopper gun. And we're only coating such a short distance, maybe a 4 or 5 foot section of these steel members that they're gonna have to do some touch up anyway. It's not a huge area to do just all at once. So I think they're finding a lot of times it's easier just to get it out there, erect it, and go out in the field and then dress it all there. Again, it can be either way, shop or field, but I think that's the reason we're seeing probably more field than shop. New construction or retrofit. I mentioned very easy application. I'll show some pictures here later of how easy the application really is. No need to top coat. I mentioned the full system, primers and top coats. A lot of times in these thermal bridging applications, it's buried in the wall. It's behind the wall, behind a soffit. Never going to see it, so no need to top coat. And biggie here is no additional engineering work, so very minimal weight gain, no need to break the steel. So it's very minimal impact in terms of the design of that structure. So here's just kind of a list of some application uses. I'd say canopies and roof supports are probably the two biggest that we see. I love this picture from this roof support. The little spray foam around there is great for maybe a little air leakage, but what about that structure itself that is now going down through the roof into the interior of the space? And that's where roof penetrations have become a very, very big one. Here's just a couple of pictures of some roof penetrations that you can see there. And here's a roof penetration for some rain screens. This is perfect sense for a shop application, right? They can do that whole little tube steel piece there, take it out, drop it in the rain screen, and they're done. But very easy application, control the film thickness and cure times and stuff in the shop. Pretty easy to transport those without damaging them. So that's a perfect application for a shop application. And again, I mentioned canopy steel. Here's just a bunch of pictures of canopy steel applications. Now, if you look at these, I mentioned 2 feet inboard and outboard, but think of that 2 feet in both directions. Think about a beach ball with going 2 feet in all directions. You're coating everything within that beach ball. So a lot of times you look at these, you got your steel beam that's coming out to support the canopy, but now it's running into a vertical column, or it's got a diagonal or a gusset plate. Everything within that 2 foot zone is getting coated. So that's why you're seeing in these pictures, you're seeing kind of the yellow coating kind of spider out in all directions within that kind of 2 foot bubble, so to speak. Again, and that's something we can kind of help highlight on drawings and details to make sure the full extent of it is getting applied. So obviously, when we think about penetrations in a building envelope, there's lots of materials that come in contact with the steel or the wall in the area that we're kind of interrupting by putting the aerogel insulation coating there. So there's been a lot of testing done with air and vapor barriers, construction sealants, fireproofing, both cementitious and intumescence, roof membranes, traffic deck systems. So we actually have about a 2.5 page list of materials that have been tested with it, that we're happy to supply just to show the extent of compatibility that have been done as we continue to add to that list. But a lot of different materials that the aerogel insulation coating plays nice with. So it really fits well into that kind of a building envelope area where a lot of materials are being used. Here's just kind of some more case history. So this was, again, a shop application. This is one of the first ones that we did in terms of using this to mitigate kind of the thermal bridging risk. This was a university student union. You can see obviously the picture in the bottom right where then they installed it. You can see the yellow on those steel beams. I always get a chuckle out of this one. This is a vestibule up in the Minnesota area, and I was the moron that showed up on site and asked the question, "What's a vestibule?" Because I had no idea. So they got a good laugh at my expense. But I know now. Obviously, get that first set of doors you open up, get in the vestibule before you get in the next set of doors to get into space. And Minnesota, obviously, very cold. They're pumping a lot of heat in this vestibule to make it a comfortable space because it's a pretty good size. So you notice in this case, we did not only the beams itself, we also did the underside of the deck as well. And this is one, again, where I had the thermal imaging camera to go in, kind of take a look at the impact that the coating had on the surface temperature in relation to the areas that didn't get it. So right before this kind of building was getting buttoned up, we were in there in a February time of year. So it's 78 degrees in the vestibule, it's 15 degrees outside. The surface temperature of the vestibule you're seeing there with that spot rating was 67.3. Obviously well above what the dew point in that space is ever going to be, and which is why in the 8 years now that this has been up and running. They have not had any condensation concerns in that vestibule. Here's a university football stadium. So these bleacher supports went down into the luxury boxes, into the suites. Obviously, a lot of conditioned air in those suites, a lot of humidity, where they're really concerned about those steels, the steel coming down there and condensing. So we took the steel on the frames, went down into the space as well, and then the steel in the luxury suites were boxed in and detailed out nice and pretty. But the aerogel insulation coating there made sure that service temperature, that steel behind the drywall, or however they boxed them in, was not condensing, and no issues there. And 2 coats, and for about 80 to 100 mils. Here's another I like this picture just to kind of highlight the whole kind of beach ball idea I was talking about. You can see there the aerogel insulation coating going on the vertical columns, going on the horizontal beams, coming down on the diagonal. So it's kind of going in all directions within that 2-foot zone. It's really kind of the emphasis of that picture, just showing it kind of going in all directions. Here's another football stadium at a university project. You may recognize you can see long enough in the middle there, the little purple Wildcats. It's obviously Kansas State University. Again, on the South End Zone project, and the aerogel insulation coating is the yellow used on all those supports there. This was a Major League Soccer stadium in the St. Louis area. You can see obviously the canopy supports there, where it's on both directions on kind of the cross there. Aerogel insulation coating was used on that as well. And this is the picture I was talking about to speak of the ease of the application. So this was actually a high school that was supposed to have the isolator pads. Not sure how they were missed, but as they're getting ready to kind of come back and button up the canopy, they noticed that there was no means for mitigating the thermal bridging risk on those canopy supports. So they called our local sales rep. He went out, did his little hand tooling, primed the area, and sprayed on 2 coats of the aerogel insulation coating. So one guy sprayed it himself. That's the handheld hopper gun I'm talking about. It's probably $75 at your local Home Depot or Lowe's store. Very easy application. So it probably took him 1 hour the first day to spray the first coat, came back the second day, another hour, put on the second coat, and kind of saved the day, mitigated the whole thermal bridging risk with 2 hours and one guy and a $70 piece of equipment. So really speaks to ease application. Again, that's why I think we're seeing a lot more field applications in shop, just so what can be done so easy and with such an inexpensive piece of equipment. So speccing this, obviously we need to spec the material. So 072163 is an official CSI spec section titled Fluid Applied Insulative Coatings. So we have a kind of a Word guide spec that we're happy to provide. We do that in Word, that way you can kind of customize it, make it your own. But 072163 is the spec section we'll reference. Now, with that said, it's always important to kind of tie it to Division 5 and tie it to Division 9. But 072163 is where fluid applied insulative coatings kind of reside. With it being in Division 7, oftentimes we'll see insulators or fireproofing contractors kind of bid on the work and gravitate towards it. But again, that's where the ease of the application hasn't really been an issue. So those other trades, that we can work with them, and it's not a challenge. Now we have better relationships with painting contractors. That's who our sales reps call in day to day, and that's who we would generally recommend to do the applications. But again, when other trades get to work, we can certainly work with them and help make it a successful application. And then that guide spec I referenced, we kind of list some performance criteria that I'll just kind of highlight real quick. Immersion. So it's a water-based acrylic. We do not recommend the product for immersion. With that said, it's got 18 months continuous tap water immersion. It was approved for offshore work by passing a 6-month, 40°C seawater immersion test. We think that a lot of that is just to the hydrophobicity of the aerogel particles in the formulation. That why it does so well with immersion. But again, we don't recommend the product for immersion. So I just highlight that data just to show that if it can handle that type of environment, it's probably safe in an interior benign office building. So it's a condition that we can handle without a doubt. Surface burning, so is a flame retardant in the formulation. So it is Class A to ASTM 84 flame spread and smoke generation. That's a very important criteria when you think about putting this inside the building envelope. So it is Class A. So that's always kind of like to highlight those two. Obviously, we list a bunch of performance criteria that I think is important to kind of speak to the durability of not only the aerogel insulation coating, but also as a system with the primer and the top coat. And we'll highlight those in the spec that we can provide. But I just wanted to really mention those main two there. So as I kind of wrap this up, obviously the aerogel particles are the magic foo-foo dust in the coating that allows it to get its low thermal conductivity, which allows us to really impact that surface temperature when we're talking about steel penetrations. It allows us to help reduce the heat loss on those concrete balcony radiator fins sticking out. So really it's the thermal conductivity of the product that allows it to kind of meet all those different criteria and be used to kind of mitigate the thermal bridging concern. So there's my contact information. If anybody is bored and just wants to reach out sometime or has any questions, I'm happy to help. So there's my contact information. Feel free to reach out if I can help with anything. With that, Bo, any questions I can help answer, I'd be happy to.
All right. Awesome. We definitely have some questions.
Okay,
so if it's, I'll just kind of start at the top. We'll work our way through.
Okay, great.
So first off, is the aerogel vapor impermeable?
It is not, and that's where we can use it with air and vapor barriers, and we have test data and kind of perm ratings and stuff that if any additional questions on that, feel free to reach out to me directly, and I'm happy to share those test results with you.
All right. Next up, what type of fire rating does the aerogel coating have, and how resistant is it to mechanical wear and abrasion?
So it doesn't necessarily, in terms of fire rating, it's not tested to like UL 263 like an intumescent would. Now it does have, I mentioned a flame retardant, so it's Class A to flame spread and smoke generation. But when I talk about like intumescence, it's been tested by intumescent manufacturers, or they put their intumescent coating, or the SFRI manufacturer, and they put that product over top of the insulation coating. And then they just kind of treat it as basically a primer system and put their materials over it. They do a little testing in-house for adhesion, small little burn tests. And then we have letters from them approving their materials over that, and then it would just fall under their UL 263 design rating.
Mm-hmm.
In terms of abrasion, it's an acrylic, so it has a little bit of a give to it, and that's really by design, so it can handle some thermal cycling. We got widths on equipment that might cycle from -20 to +250, so there's some thermal shock involved that it needs to be able to handle. So that's why it has a little softness by design. The abrasion numbers are actually pretty good on it as a result. But if it was in a more aggressive environment, that's where we would utilize a top coat appropriate to handle whatever the environment consisted of.
Mm-hmm. All right, great. Let's see. Maybe we need some context on this one. Would that work similarly? Okay, thicker on the exterior if there was a desire to expose the steel on the interior, but not wanting to see the coating.
Yep, and we can do that either direction. I think I mentioned putting it just interior and not losing an exterior, but we can do vice versa as well. Now, when we do just exterior and leave the interior alone, we got to go even a little thicker when we're only using it on the exterior. But we do have the ability to kind of tailor that coating thickness and where we're applying it for a given project.
Mm-hmm. All right, great. Does the slab coating application work the same for a concrete roof condition that might have an overhang?
That's a good question. So it would, to an extent. I mean, so the roof, I think about the roof, you got kind of two conditions where you got the one side and the bottom. Are you talking? So I guess that would be one if we're looking at doing the entire roof or just where it's hanging out. But we've done some just interior roof applications for that similar application. We've also, a lot of times they'll do that where they'll just maybe put a reflective coating on the roof as well. So there's kind of combining the two. There's ways we can certainly come up with a system that helps there too.
Mm-hmm. Any issues with compatibility with spray-on fireproofing or intumescent coatings?
Nope, and that's where we have letters from a wide range of manufacturers that we've tested with. which we're happy to provide. But I have not seen. I can't think of a product where we've requested testing where it didn't pass in terms of SFRMs or intumescence.
Mhm. All right, great. This person asks, it looks like most of your examples are in northern climates. Do you see the aerogel coatings used in hot climates as well? I live in Arizona. I'm curious if this would help with heat transfer as much as it does cold and condensation.
It does. So the concrete balconies, especially, so we had that kind of modeled in like 7 different climates. Miami, Florida was one of them, and the results were very similar to the model we did in Vancouver or the one we did in New York City for the concrete balconies. In terms of steel penetrations in like a Phoenix area, not a lot of humidity, so it's probably not as important on steel applications there. But I will say, like I'll be in Atlanta next week, kind of giving this presentation to an architectural firm where they're seeing this certainly thermal bridging concept kind of move a lot farther south than what it did when we first started doing this, I would say 7-8 years ago. But yeah, you're correct in that the majority, I would say 75% of our applications are probably north of the Mason-Dixon line on steel penetrations, but the balcony applications for sure are spreading southward.
Okay, awesome. All right, let's see. We've always heard that aerogel is very expensive or isn't widely available anymore. Could you speak to that?
Yeah, I mean, aerogel is not a cheap additive by any means. And this coating is a reflection of that. Where I'm not gonna sit here and lie to you and tell you it's a cheap coating because it's not. But we're also only using it on such a small surface area in relation to a lot of the coating work, and in comparison to other means of mitigating thermal bridging, it is generally the cheaper alternative.
All right, awesome. How do you treat tube-shaped members which are hollow and allow air to go through?
That's a great question on tube steel. So usually tube steel, I mentioned, 2 coats, 80 to 100 mils for our generic recommendation. Tube steel, we'll add a 3rd coat. So you're talking 120 to 150 mils on tube steel. And we'll also typically ask that we'd like to see them, insulate it and cap the tube steel itself. Or fill it and cap it, I should say.
Right, great. All right, let's see. How about any periodic maintenance?
Not really. I mean, it's, you get a good corrosion resistant primer and aerogel insulation coating, and then in a lot of the cases, in these type of applications, it's never seen. It's buried in the wall, and it's there for what we would say the life of the building. Now we're putting it on industrial oil tanks as well with a top coat, and they may do some minor repairs there. In terms of, someone slams into it, they might do some minor touch up and stuff there. But otherwise, in this type of environment, I don't envision a whole lot of repair work needing to be done.
All right, great. Let's see. Is it suitable for use along the exposed slab on grade edge in residential construction?
It would be, yes. Again, and that's where we would certainly get a top coat, just one for wear and tear and also for color.
All right. Could you explain how the coating outside the steel prevents heat transfer inside the steel?
When you think about heat transfer, really happens on the perimeter of the steel. So by coating the perimeter of the steel, we're raising that surface temperature, so that steel temperature along that steel is getting warmer and warmer as the coating goes, so that when it gets inside, it's a lot warmer in the surface of that steel. Think about putting a sock on in the wintertime. Obviously, your foot's pretty cold. You stick it out in December morning, stick out underneath the covers, your foot's cold, but you do the same thing with a sock on, and that your foot feels a lot warmer. So basically, we're just putting a sock on that steel beam and just getting that surface temperature above the dew point.
It's a great analogy. All right, can it be colored to match the adjacent paint? What about ASTM 285? I don't think I heard that mentioned.
So the aerogel insulation coating itself comes in 2 colors. It's a yellow and an off-white, kind of lemonade white, really. And really, there's just two. The second color is just when you're doing multiple coats. Some contractors want to do a different color just to alternate colors between coats to see where they've been. So any sort of long-term coloring would need to come from the top coat, and that's where the top coat, can come in any color imaginable. In terms of ASTM 285, because I'm not sure that I do get asked about NFPA 285 a fair amount, and if NFPA 285 is what the inquiry is really about, I would encourage that person to reach out to me directly, because I have some engineering evaluations that have been done by other manufacturers that incorporate the use of our product into their NFPA 285.
Mhm. All right, great. And then looks like this might be our last one. So if anyone else has questions, now is a good time to submit. Can it be used as a finished surface, and how does it stand up to ultraviolet light and sunlight?
So it could be used as a finished coating. So we had panels on the roof of our plant for 2 straight years with and without top coat. And what we did is, with those panels, every month we'd pull them down and recheck thermal conductivity. And over the course of the 2 years we did that, there's really no difference in thermal conductivity with or without top coat. The nature of having a flame retardant in the product just makes it yellow even more to any sort of UV exposure or even just ambient light. So if you're concerned with any sort of color stability at all, I would top coat it.
Mm-hmm.
But in terms of functionality or thermal performance, it's okay without one.
Mm-hmm. All right, great. Awesome. Well, it looks like that might have wrapped up all of our questions. So just want to thank everyone in the audience so much for coming out today and asking so many great questions. There will be a quick post-event survey as you're leaving today. If you've got some time to fill that out, that's super helpful for us to get some of your feedback there. You can also feel free to drop any questions there that might come to you as you're leaving. But yeah, would appreciate anyone who could take some time to fill that out. Let us know how today's webinar was for you. Andy, thank you so much for a great presentation and for the rapid fire question answering. Really great to get so many questions. So appreciate you coming out today and presenting for us.
Perfect. Thank you. Appreciate everybody's time. Have a good rest of your day.
Thanks, everyone. Have a good one.